Hey, so today I have a philosophical Wednesday as usual, and we will talk about knowledge graphs. And you know, I see emerging topic of the hypergraphs, and more we work with the uh, complex artificial intelligence tasks, building memory, working with the multilingual and multimodal data. The more we see the limitation of the classical directed graphs. And it's understandable because simply triple is too limited. I wrote a lot of articles about why the triple is limited and why we need something more. And just to quickly recap what the hypergraph is. So it's the generalization of the graphs that allows you to have the edge that connect instead of two nodes, the multiple nodes. And actually you connecting the set of nodes with the edges. And in some extensions, you could have the directed hypergraphs where you have the set of the from nodes and set of two nodes and all of the things, and you could say that you could have the direction. It's worked quite well. It's solved a lot of problems, and it's a nice data structure. But the problem is that you're quite limited because sometimes we want to point to these complex sets as a nodes, and then you have a challenge, right? Because the hypergraphs mathematically not suitable for this. And the next level of complexity, actually from the hypergraph, it's the metagraph. And metagraph actually it's the most general thing that actually bring the homomorphic structure to the graph because you do not really have the difference between the node and edges, and the nodes could contain the graphs inside, the edges could contain the graph inside, you could change the context. In some context, the edge could work as a node, the node could work as the edge, and all other things. But the challenge with the metagraphs that they really have this fractal structures that they could mimic some complex repeatable patterns. They have the ability to build the hierarchies, and we need the hierarchies actually for the semantic memory that have the hierarchy structures and all the things. So you have the fractal structures, you have the hierarchy structures, you able to bring the homomorphic nature and keep the metadata together with the ontologies, together with the data in the same graph. So the metagraphs look super cool. I wrote a couple of articles how to model the metagraphs in the relational databases, but challenges that we don't have enough of researches around the metagraphs. I was capable to find only one book about the metagraphs, to be honest. And another challenge is with the metagraphs that we don't have any kind of modern database that ready to model all this complexity. So then what kind of solution for this challenge actually we could have? So what I'm doing currently that instead of some hypergraphs or metagraphs, I just go with the regular graph that capable to model the complex relations as a nodes. Yeah, so that's the compromise that instead of the heap edges, we have the meta nodes and that represent the edges. And then we have all the tooling, all the databases and all other things that allow us to work with the nodes. So it's quite node centric, but you represent your edges as a node. So that I guess it's the good compromise. And another quite interesting data structures. It's the graph of graphs, but it's you have the nesting, so you could have the graphs inside. at the nodes, and you have the ability to build the hierarchical structures in this setup. Yeah, and they wrote multiple articles about this also, but the problems with the hierarchical structures that, from my humble opinion, the LLMs doesn't understand it well. And even with the complex subgraphs, I take this decision to project them to the plane graph and to materialize the subgraphs. What I mean, that I really have the entity that represent the whole subgraph, then have some properties and summaries of the subgraph, and it live on the same space as the rest of the nodes. So you have quite specific nodes that could represent edges, and some specific nodes that could represent the complex subgraphs, and they live on the same space, so we have completely flat structure, and we leave the understanding of the semantic of these structures up to the ontology and application level. So it's still the good compromise of using what we have while waiting for somebody who will bring us the superpower of the metagraphs. I don't have the proper name for this structure, but it's quite practical, I would say.